So I'm really very pleased to introduce you to Michael Schick. And he comes with a double role, I would say. First, he is the principal engineer of EUMETSAT, and EUMETSAT is an organization based here in Darmstadt. So that's the first thing, and as you know, the European Organization for the Exploitation of the Meteorological Satellites. And we have learned that there is a data culture here in Darmstadt. But very importantly, he's also the system manager of Destination Earth, Data Lake. Yes, and that's very important. Destination Earth, as you know, is a big program to create the digital twin of the Earth. And it's very important for data spaces. We were inspired by the Green Deal data space. And we know you need data spaces. Data spaces also need Destination Earth. And that's the reason why we have Michael today. Thank you very much for joining us.
So good afternoon, everyone. It's a pleasure for me to talk here in Darmstadt, where I'm actually born. And I've spent a decade at ESOC, at ESA working, and another 2 decades at EUMETSAT. And I'm talking today about Destination Earth and see how that is in context of data spaces. So Destination Earth is a flagship initiative from the European Commission to develop a digital replica of our planet to respond and adapt to climate change and extreme events. So it's a joint undertaking in conjunction with the Euro HPC, and it actually exploits HPC infrastructure, and it makes it available for the users and the community. So before, HPCs were not directly available for users to interact with, so to run scenarios on demand, to get access to the data. And we're talking here about a really large amount of data, so it's petabytes. So the Destination Earth provides Earth system information at scales where impact of extreme events and climate change are really felt. And we see how the climate changes and which extreme events occur all over the world, and with this we can face some of the challenges. So this system enables as well artificial intelligence, and Destination Earth is part of the European Green Deal data spaces. In the context of the conference here, I guess there were some sessions which talked about the GREAT initiative. I mentioned later that as well. And the Euro HPCs on which we run the Destination Earth initiative is in the moment on 3 HPC computers, which you can see here on the slide. It's Lumi in Finland, it's Mare Nostrum in Barcelona, and Leonardo in Bologna. And these HPC computers belong to the top 10 in the world. Destination Earth, I just mentioned here the roadmap. It's a framework which we have established now. So we started actually 2 years ago, and we are now at the end of phase 1. And at the end of phase 1, we are finalizing the delivery. We're going into the transition into phase 2, and actually the system is launched to start operations in June. So in June, we will have the inauguration event, potentially at the HPC in Lumi. And from there on, the system can be used. But the system is not finalized as such, because we will have user engagements, workshops with users, the portfolio will evolve, but also the services and the functionality. So, and there are many other initiatives with which we have to integrate. So with data spaces, with other digital twins, whatever is going to come. So what is it? What can be answered with Destination Earth? And in particular, what it depicts is to be able to answer what-if scenarios. And I put here on the slide two examples of what could be thought of. So in the area of renewable energies, there could be questions like there's a storm coming and how it affects the energy production, or where to effectively put a wind farm in 10 years of a time and how the climate changes. Or questions regarding temperature rise in the future. So these kind of things can be done with Destination Earth and with the data available there. So We are not alone implementing Destination Earth. It's implemented by 3 entrusted entities. So EUMETSAT is doing the data lake, which I focus here today, because it has also the connection to the different data spaces. But ECMWF is implementing the digital twins, the climate adaptation twin, and the extreme weather twin. And we have ESA implementing the core platform, which is actually user-facing with services for the user to exploit and access the data lake and interact with the twins when necessary. Here on this slide, you see a kind of scenario that is run on the Destination Earth data lake. On the left side, you see the core service platform where users actually come in. They access and discover services and data. Then they can actually use AI/ML applications. They can run hosted applications. They can use virtual machines in clusters. They can access digital twin data. And they can run workflows to take information and results away. On the right side, you see the 2 twins, and then top and bottom, some data spaces. So I don't explain Destination Earth as a whole with all its services. I focus today on the data lake itself. The core platform where the users are facing, they have many services on top of this, but I'm just focusing here on the functionality of the data lake because it has some direct link to the data spaces and why you're here today. So on a sort of like a small Bierdeckel, we would say in Germany. So you see here on this diagram. So in the center, you see the 3 main services: discovery, services, and data sets, the data access itself, and then big data processing services or near data processing services. These services actually make use of edges, edge computing. So we have bridges or edge computers near the HPCs because it's impossible to transfer all the data out of it. So 1 year of climate adaptation twin data produced for 1 year produces 1 petabyte of data output, and that is generated in about 10 hours, roughly. So that amount of data has to be taken in a suitable form and transferred. It will be transferred onto the bridges so that it can be exploited. So we're talking here about 1 year. But a climate scenario, we have several scenarios using different models. And in a climate scenario, you can have 50 to 70 years of data. So, and you can then do a basic calculation how that sums up. So it's impossible actually that people come to our data space, take away 70 years of data into another data space. So we need efficient methods in order to do processing near the data or the data exploitation or taking data out. So what we do is actually we have edges, and on the edges, on the right side, you see digital twins. Destination Earth starts with 2, but in the future, we will have more twins. There's maybe a biodiversity twin, there are smart cities twin, whatsoever. We connect, and we have data from there, digital twin of the ocean, and then you want to actually fuse the data. You need to put the data together. So if you want to use AI/ML or machine learning, you need to put the data efficiently together. You put it in the same projection, spatially, temporal. You need to do corrections of biases, etc. And on the left side, you see the various data spaces, which also need data to be pulled in, because in the questions that I showed before need to be answered with data from other data spaces. So with climate data on its own, you cannot answer the questions. Energy sector needs climate data and vice versa. So there is really a need to go from one data space to another, but we cannot put everything in one place together, but we need to efficiently exchange. So on the data portfolio, I will not talk much about it. So you see there on this nice diagram, different data spaces. And so it's not only Earth observation data. We have also sensor data, IoT data, all kind of in-situ data, all kind of other data, which plays a role and comes in. I mentioned before, on the data portfolio, in the Destination Earth data lake, you can look at this picture here. You see what I described before in terms of the outputs. You see the DT is the abbreviation for the digital twins. You see the climate adaptation digital twin and the weather-induced and extreme twins. And you see here what is being produced daily and annually. And we have in the Destination Earth data lake, we have as well so-called fresh data, which is data already pulled into the lake, which is needed for exploitation of use cases or AIML sort of model, training data set generation or model execution, so inference. But then on the other side, we have the so-called federated data, and the federated data is what we connect to other data spaces. And the volumes that are listed here are bigger than what you see there. So in the fresh data pool, we have actually today 50 petabytes, and federated data is also much, much more. On this slide, you see then how Destiny is seen in the context of the common European data spaces, and there may be as well in this conference some talks about the simple infrastructure and the simple initiative. And it's also an initiative from the European Commission, and it's a smart middleware which shall enable cloud-to-edge federations. And it should support also all major initiatives funded by the European Commission, so other data spaces, in order to interact. On the diagram on the right side, on the network, you see how it's meant to be used between different initiatives. And the Lego bricks is not entirely complete. It's sort of how it's been started. So the initiative, Simple, has just been launched, is ongoing, and I think a first sort of implementation is awaited at the beginning of next year. So here I put something together for you, which, for my opinion, is interesting for consideration of different data spaces. So on the top, you see the Pangeo initiative with a zoo of tools. And I think we've used those in the Destination Earth data lake in order to allow near data processing, to allow the loose coupling, etc. And I think the collection of that is not mandatory to be used all together. You can use them individually, but they're really cool in order to achieve and to manage to process a large amount of data. So I think what is important is that between data spaces, we have to be loosely coupled. It's very important. And it has to be the federated approach versus a monolithic one. So because we've seen in the past how things evolved, and I really believe you have your community in the different data spaces, and we need to be able to interact, ideally very loosely coupled and with easy-to-use tools to explore the catalogs, and to be able to exchange information, but only exchange information towards what is really needed. And I think we have to go beyond FAIR. I mean, FAIR is great in order to describe how data is accessed and metadata, etc. So FAIR, as you know, stands for findable, accessible, interoperable, reusable, and ideally on an open license. So as open as much as possible is great, but as close as necessary is needed. And I think I was here a bit provocative. So we have to go towards first. So it's a bit close to FAIR. But I think what we need is the last two. So we need to be able to stream, and we need to be able to transform. So in a data space, we need to have the option. So for example, if we have the 70 years of data, you don't want really to transfer all out and then start to transform the data and cut. So you want to do it close inside the data space. You want to have services that you can do already some transformation and really stream out what is needed into another space in order to answer and perform your use case. On the right side on the diagram, you see a snapshot. I took it out of the GREAT initiative. So it describes the kind of requirements and the approach, how data space federation could be done. And on the bottom is again a reference to Simple. So this is one of my last slides. So towards AI fact, and AI factories, and data spaces. So I was lately on the Euro HPC governance board. So we had the pleasure from Destination Earth to be at the Euro HPC governance board and listen to them and present as well Destination Earth, because we need on the HPC quite a big amount of compute resources in order to run the models. And we need to run scenarios and models as well in the next years, not just today for the opening. And so we need to be granted a percentage. And so when discussing with them, we heard as well what their plans are towards the future. And also from the European Commission with the AI Act being in place in December. So they came out with a message that they want to build on AI factories. But really running large models requires HPCs. And the HPCs, in order to run large models, need data spaces. They need to get data into the HPCs. And in order to be efficient and efficiently use GPUs, you need to stream the data in, such as the GPUs are not idle. And you have to really optimize the usage. And here, there's really a need on the data spaces to be really efficient and take the subset and stream that there. So we need as well then the AI-ready data to facilitate and prepare data to be usable for AI. So that completes my presentation. Here's a link to Destination Earth. You can go to the website. You can read more details about Destination Earth itself, the components, the launch, and follow that up. Thank you very much.